Welcome to PreMath. In this video, we have got these two identical blue circles and two identical pink circles fully inscribed in a rectangle A, B, C, D, as you can see in this diagram. And moreover, all of these circles are tangent to each other. And the area of these blue circles is pi centimeter square each. And furthermore, this diagonal AB is 10 centimeter. And now our task is to calculate the total area of these two pink circles. Please don't forget to give a thumbs up and subscribe. And please keep in mind that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Before we do anything else, we must find the radius of this blue circle and this pink circle as well. Let's assume the radius of this big blue circle is uppercase R, and the radius of this pink smaller circle is lowercase r. And now we are going to calculate the value of uppercase R and lowercase r first. And here's our next step. Let's focus on one of these blue circles. The area of this blue circle is 4 pi centimeter square. And now let's recall the area of a circle formula. Area equals to pi r square, where uppercase R is the radius of this blue circle. And since the area of this blue circle is 4 pi centimeter square, so therefore I'm going to replace this area of the circle by 4 pi on the left hand side. So therefore we can write 4 pi equals to pi times uppercase R whole square. And now we are going to divide both sides by pi. This pi and pi is gone, pi and pi is gone on this side as well. Let me go ahead and undo this square by taking a square root on both sides. Here square and square root is gone. So therefore our uppercase radius R turns out to be 2 centimeter. And here in this next step, I have drawn this blue straight line that is parallel to this side AD. And now let's recall this crucial fact. The centers and the point of tangency are collinear. In other words, these centers on this blue line and their point of contact, the point of tangency, they lie on the very same line. And now let's make an observation. We can see that this is the radius of this blue circle, and we know the radius is 2. So this side, this radius is 2. Likewise, this is radius as well. So this is going to be 2. 2 plus 2 is going to be 4 diameter, and this is the diameter 4 of this identical blue circle. So this is going to be 4 as well. So therefore this whole length is going to be 4 plus 4 is going to be 8 centimeter. And since this blue line length is equal to this AD side length, if this is 8 centimeter, then AD length is going to be 8 centimeter as well. And now let's focus on this right triangle ADB, whose this side length is 8. This AB side length is 10. And now we are going to calculate this unknown side length. And now let's recall the Pythagorean triplets 3, 4, 5. And if I multiply these triplets by 2 across the board, then our new sets of Pythagorean triplets are going to be 3 times 2 is going to give us 6, 4 times 2 is going to give us 8, and 5 times 2 is going to give us 10. And since we know that this number is 8, this AB is 10. So therefore this unknown side is going to be 6 centimeter. So therefore our BD length turns out to be 6 centimeter. And by the way, you may use the Pythagorean theorem to figure out this unknown side length. And in this next step, I have created these horizontal and vertical lines, as you can see. And now let's recall the circle theorem. According to this theorem, the angle between the radius and the tangent line will always be 90 degrees. So no wonder all these angles are going to be 90 degrees, since these are our tangent lines and these are our radii. And now in this next step, I have connected this center O with this center P, and as a result we got this right triangle PQO. And now let's focus once again on this triangle PQO. And now let's make an observation. We can see that this whole BD distance is 6. So therefore this FQ length is going to be half of 6. So that is going to be 3. Let's assume that this FP is the radius of this pink circle. I'm going to label it lowercase r. Then this PQ length is going to be 3 minus r. So I can write 3 minus lowercase r. And furthermore, we know this radius OQ is 2 centimeter. We already figured out. And finally, this radius is for blue circle, which is 2. And this is the radius lowercase r of this pink circle. So therefore this OP length is going to be r plus 2. And once again, let's recall this crucial fact: the centers and the point of tangency are collinear. So no wonder the centers OP and this point of tangency are collinear. They lie on the very same line. And now let's focus back on this triangle PQO, whose side lengths are 3 minus r, 2 and r plus 2. And now we are going to apply the Pythagorean theorem on this triangle. And here's our Pythagorean theorem: a square plus b square equal to c square. Let's go ahead and fill in the blanks in this Pythagorean formula. So we are going to have 3 minus r whole square plus 2 square equals to r plus 2 whole square. And now let's recall this famous identity: a minus b whole square could be written as a square minus 2ab plus b square. We are going to apply it on this binomial on the left hand side. So therefore this is going to become 9 minus 6 r plus r square plus 4 is going to be equal to, and now let's recall another famous identity as well: a plus b whole square equal to a square plus 2ab plus b square. We are going to apply it on this right hand side binomial. So therefore this is going to become r square plus 4 times r plus 4. And now we can see r square and r square, they are gone. And moreover, this 4 and 4 is gone as well. And now we are going to add 6 times r on both sides. This is gone. Let's divide both sides by 10 to isolate r. This 10 and 10 is gone. So therefore our lowercase r value turns out to be 9 divided by 10 centimeter. So therefore the radius of this pink circle turns out to be 9 divided by 10. And now let's go ahead and calculate the area of this pink circle. And now let's recall the area of a circle formula: area equals to pi r square, where lowercase r is the radius of this pink circle. So let's go ahead and fill in the blanks in this formula. So we got pi times our radius r is 9 divided by 10 whole square. And if we simplify everything on the right hand, that is going to give us 81 pi divided by 100. So therefore the area of this 1 pink circle turns out to be 81 pi divided by 100. So therefore the total pink circle areas for both of these pink circles is going to be 2 times this number. So therefore I'm going to multiply 2 times this 81 pi divided by 100. If we simplify the right hand side, this turns out to be 81 pi divided by 50 centimeters square. So thus our total pink circles area turns out to be 81 pi divided by 50 centimeters square, and that is going to be approximately equal to 5.09 centimeters square. Thanks for watching, and please don't forget to subscribe to my channel for more exciting videos. Bye.